Hi. Okay, here we go. Chapter 5. This is Chapter 5 and 18. This section is all about biodiversity and saving biodiversity. Chapter 5 starts out with a great little story talking about how a lot of our current medications have come from plants. Arroyo willow is aspirin. Digitalis comes from, I think it is the periwinkle. No, that's leukemia. There's different things. So the fact is, we should be preserving as many plants and animals as possible because they might be our future cure for cancer or other diseases. But unfortunately, we're not doing that. We need to be very careful, but we are not protecting biodiversity like we should. Okay, as we start into this chapter, some vocabulary you definitely need to know. Evolution, genotype, phenotype, mutation, recombination, artificial selection, natural selection, genetic drift, bottleneck effect, founder effect, allopatric speciation, and sympatric speciation. And we're going to go through most of that. Diversity. There's 3 types. Ecosystem diversity, also sometimes called habitat diversity, species diversity, and genetic diversity. All together, they ultimately make up what we call biodiversity. Ecosystem diversity is exactly that. It's variation within your ecosystem, having more, not just solid forests, but there's rivers and ponds and meadows and things to make more variation within habitat, which actually can support more different species. More species, or species diversity is exactly that. It's the species within the area, the different variety of species. So the more variety of species you have within an area, the better it is. The more complicated your food web is going to be, the better it is going to be for. So as we talk about and we use different ways to calculate biodiversity in class, a more evenness within your calculations will actually create a higher value for the biodiversity, and you'll see that tomorrow or in class. Okay, moving on. Let's talk about evolution. Talked about it a little bit in class today. All evolution is a change in the genetics within a population over time. Does not mean you're going to get wings or a tail or something like that. You can have microevolution, which is variety in the species, and then macroevolution is actually will create a new species. And we're going to talk about speciation, or the creation of new species, because of course creating new species actually creates biodiversity, because the more species you have, the greater biodiversity you have. Okay. So genetic diversity, we can get genetic diversity through mutation, which is a mistake in copying that can actually give you some variation in genetics. And then we can have recombination, which is a piece of one chromosome breaks off and attaches to another, which can give you new traits. So both of those can lead to genetic diversity. If that genetic diversity is good, helps an animal adapt or survive, then that will carry on. If it doesn't, it couldn't be eliminated through predation or something if it's not favorable. Okay. Artificial selection, that's basically us choosing to do something, like the dogs down below. We choose through breeding to create variety within a species. So we've done this with dogs, fruits, vegetables, horses, chickens, cows, all kinds of things. We've bred breeds. So there's different breeds of cows, different breeds of dogs, different breeds of vegetables. There's all different types of tomatoes, and those are because we've artificially selected for different things and created them. But they're all the same species kind of thing. Okay, moving on. Running through this kind of fast. If you have any questions, please ask in class. Natural selection. It's driven by the environment. There has to be a pressure for natural selection to occur, something like predation, competition, or disease. What happens is, because of predation, competition, disease, some kind of natural driving force, there's a favorable trait. That individuals with that favorable trait are more likely to survive and therefore more likely to reproduce. However, it is not natural selection unless they reproduce and pass that genetic on to their offspring. Oops. Sorry, I'm having issues with my computer. Things popping up. Natural selection requires things. You have to have a lot of offspring born, more than can survive. If you only have 5 born and all 5 survive, you can't have natural selection. Some of those offspring have to die. Really, the ones that don't have the favorable trait have to die, or at least the vast majority of them. That genetic variation within the population has to occur. If everybody's identical genetically, you can't have natural selection. The trait that is favorable has to be genetic. It can't be like tool use, which is taught. It has to be actually something that's genetic and can be passed on through reproduction. And that favorable trait has to have an increased chance of survival, or give the organism that has it an increased chance of survival. That way, they're more likely to survive and pass that trait on. Over time, you get animals that adapt to new situations, and that is natural selection. So adaptation really is just natural selection. So an example given in your book is the crustaceans and the fish. Fish likes to eat the large crustaceans, so they eat those, more likely to eat those. The little ones survive. The little ones pass on their trait to be little, and pretty soon the entire population is little because you are more likely to survive. That's a better trait. So there you go, natural selection. So it doesn't necessarily lead to something big. It can lead to little things like being a little bit smaller or preferring seeds rather than insects and that kind of thing. We do have evolution through random processes, just things that happen. Mutation is one of them. We already talked about that. Genetic drift, which is just random mating within a small population. Bottleneck is when your population is reduced very rapidly, and that a small population survives, and that small population probably has a different makeup than the original population, because not all of the genetics survive, so then the resulting population is going to be different. And then founder effect is when, similar to bottleneck, when a small part of your population is relocated, like to an island or a zoo, and you get your resulting population is different. So there's pictures of that here, kind of depicting that. Cheetahs have gone through a bottleneck. Their numbers got highly reduced. All these individuals die except for the small little population that survives. That's the bottleneck. And then when you come out, there's much less genetic variation, which is what we're seeing in cheetahs, which means they're highly susceptible to disease. This one here, this is your founder effect. We have a large population. A small group of that population is relocated in some way to an island or a zoo, and the resulting animals that result from the small little population, because that little population or those few members of the population who are chosen probably do not have the exact same genetic makeup as 100% of the other population, and so they will change over time. So there you go. Any questions, let me know in class. I'm going through this pretty quick, but that's okay. Speciation is actually one of the big things we need to talk about, because speciation leads to new species, and more species means higher biodiversity, so that's always a good thing. There's 2 types of speciation. You can have allopatric speciation and then sympatric speciation. Allopatric speciation occurs due to geographic isolation. It's basically like the founder effect. For some reason, the 2 populations get separated by a mountain range or a river or the ocean, and you end up with a founder effect situation where over time the 2 populations change and become reproductively isolated because of the geographic barrier that they cannot get across, and result in 2 different species in the end, and create a new species, which is very important. And this is how most organisms and most species actually get created. Sympatric speciation is created or done by polyploidy. Most organisms have a set number of chromosomes. Humans have 2 sets of our chromosomes. But through reproductive isolation, or through genetic alteration, mutation, occasionally it happens that species get more sets of chromosomes. So you can have an individual with more than 2 sets of chromosomes, and that's polyploidy. So if you're diploid, you have 2 sets, and if you're polyploidy, if you have more than 2 sets, and what happens is they become reproductively isolated. If a diploid and a polyploidy organism actually breed, the baby's sterile. It can't reproduce because they actually become new different species. So they become what we consider reproductively isolated. Both of these result in speciation or creation of new species, and that increases biodiversity, which is very important. Okay. Pace of evolution. In this part of your book, it talks about 4 factors and how what they have to do with the rate of adaptation or evolution. Environmental change. The fact is, species can adapt if environmental change occurs very slowly. So if something is happening and it happens very slowly, animals and plants can adapt to it. Not a problem. But if it happens very, very quickly, within a couple of years, most animals and plants cannot adapt that quick. And so they are much less likely to survive or be able to adapt to the new situation if it happens very rapidly. Which is one of our concerns with climate change, that it's just happening very fast and animals and plants just cannot keep up with it. Genetic variation. The fact is, the greater the genetic variation you have in a population, the more likely they are to be able to adapt. Feel like it. Yeah, that's better. You have more traits. More traits are more likely to be able to, some of those traits are more likely to make the animal more likely to be able to survive situations. And so your population can adapt much better to situations when there's a high level of genetic variation. Population size. Population size is kind of a crazy one, because actually small populations can adapt much quicker and to some degree much better, because you're trying to change a smaller population and they can just change faster. So population actually, even though larger populations have more genetic diversity, which is usually a better thing, small populations can actually adapt quicker, because there's just less individuals whose genetics need to change. So that's kind of a weird thing. And then generation time. How much time does it take an individual to mature so that they can have their own offspring? The shorter the generation time is, the faster an animal can adapt. Rodents, they're having babies within 6 weeks of themselves being born. It's 12 weeks within their birth. So they can reproduce very fast and they can change very fast. If you have a tree that has to be 50 years old before it produces seeds, or sea turtles that are 50 years old before they start nesting, that's going to be very hard for that population to change quickly. They just cannot do it. So they are going to be much more likely to not be able to adapt. So shorter generation time allows you to adapt much quicker to situations and more likely to be able to do that. Okay, let's see here. GMOs, rapid genetic change, man-made. Okay, let me cut it off here and we will talk about range of tolerance in the next video.